This journey will take us to some of the most unusual galaxies found in the vast emptiness of deep space. Covering billions of light years of space, we will plunge into the mysterious depths of giant voids, and then get to the furthest reaches of the meta-galaxy. This will allow us not only to see the distant past of our universe, but also to take a peek beyond its borders. Let's get ready, and we begin. Long before telescopes had been invented, people could observe a light strip crossing the heavens. The fascinating and mysterious phenomenon prompted a multitude of legends, but it took thousands of years of scientific progress to finally account for it. It turned out that the Milky Way wasn't a path of gods. What it is the dissipated light of billions of stars too remote to distinguish each one separately. The idea of the stars around us making up part of a single structure of enormous dimensions was first suggested by Immanuel Kant back in 1755. He also assumed that some nebulae discovered by scientists could in fact be remote star clusters, that is, other galaxies. This ingenious guess was well ahead of its time, with the philosopher's contemporaries initially dismissing it. Only in the early 20th century did the progress of observation equipment enable scientists to confirm the existence of other galaxies, and in 1936, Edwin Hubble devised a classification system. Many of its principles are still referred to by scientists today. According to this system, the Milky Way falls into the category of barred spiral galaxies, although it took a long while before it had assumed its today's looks. Our galaxy is quite an old one, since the stars in its central globular clusters were born as far back as around 13 billion years ago. At the same time, there are some areas in the Milky Way where stars are actively born, which means that there is always a fresh supply of young stars. The collected data points to the fact that the Milky Way is a comparatively large galaxy in astronomical terms. The diameter of its disk measures as much as 200,000 light-years. With a halo reaching out into space much deeper yet, our galaxy is home to at least 200 billion various stars, as well as 25 to 100 billion brown dwarfs. In addition, it contains over 1 trillion planets, countless small celestial objects, as well as clouds of cosmic dust and interstellar gas, which may reach gigantic dimensions. At the same time, regular matter accounts for a small ratio in the galaxy. Around 90% of the Milky Way's overall mass is the so-called dark matter. The amount of light emitted by this mysterious and widespread substance is negligible. However, dark matter plays an active role in gravitational interaction. Even though most of the galactic mass remains invisible, we can still calculate it. To that end, scientists refer to stars' trajectories of movement around the center of the Milky Way. According to the estimates, the overall mass of our galaxy reaches 0.8 to 1.5 trillion solar masses. The structure of the Milky Way is quite elaborate. This area of the galaxy is shrouded in massive clouds of gas and dust, but by happy chance we can observe it through the so-called Bardes window, an area of space with lower amounts of dust. Just like most spiral galaxies, the Milky Way has a supermassive black hole in its center, which is surrounded with an accretion disk with a radius roughly 3 light-years. Dubbed Sagittarius A star, it is the closest object of this class to us. Its mass is 4.3 million solar masses, and its radius isn't over 16 million kilometers, which is 3 times smaller than Mercury's orbit. The first data about the nature of the object in the center of our galaxy was acquired in the course of long observations and thorough calculations. Only as recently as on May 12, 2022 was it possible to get the first image with the help of the EHT network of radio telescopes, and so the earlier hypotheses were confirmed. The area in the center of our galaxy is highly populated. More than 6,000 stars have already been detected within 3 light-years from the black hole, with the orbits of some of them defined rather accurately. For example, there is a white-blue star, designation S62, which is 17.8 astronomical units away from the black hole on its closest approach to it, while moving at 6.7% the speed of light. Classical mechanics laws are inadequate for description of the trajectory of movement of a star as swift as that because of relativistic effects. Just to illustrate, the axis of its orbit shifts by 75 angular minutes with every completed orbit. Besides, when crossing this area in space, we can see several large star clusters with a total mass of around 1 million solar masses. And slightly further, roughly 200 light-years away, another massive black hole is likely to be lurking, whose mass should be around 100,000 times that of the Sun. Traveling further on, we will reach the central molecular cloud, an irregularly shaped area measuring 1600 to 1900 light-years, whose mass is over 60 million solar masses. There are a great many stellar nurseries and gas nebulae, as well as protostars and remnants of supernovae. Most of the cloud's matter is dense hydrogen, whose temperature fluctuates between 50 and 600 Kelvin, which corresponds to 223 degrees Celsius below zero to 327 degrees Celsius above zero. Spectral analysis shows the gigantic nebula to contain carbon monoxide, methyl alcohol, and hydrocyanic acid in addition to hydrogen. Having receded from the Milky Way's center a bit, we will see that it is encompassed by a bulge, a bright and massive formation of an elliptical shape. With its length reaching 10,000 light-years, its transverse diameter is roughly 7 light-years. The total mass of the bulge is as much as 10 billion times that of the Sun. The exact number of the stars cannot be calculated because their radiation blends and renders any estimates unrealistic. Being elongated, the bulge forms the so-called bar stretching for approximately 13,000 light-years and serving as the base for spiral galactic arms. It is here, at one of its ends, that we can see the star cluster Stephenson 2, containing the largest known star today. Its designation is Stephenson 2-18, and its radius is 2,150 times that of the Sun. Unfortunately, chances of finding exoplanets orbiting this outstanding object are quite minuscule. Even if planets did exist at some point in the past, the hypergiant would have swallowed them up while it was expanding.